Welcome to the Crazy Hat Chemist. So here we go. Equilibrium and reaction rates, video number 22. Bam! Okay, this is a complete summary of thermodynamics. Some of this will be very similar to the previous lecture, but I'm going to add some more onto this here. So here we go. Good review. So this is the equation that we're working with. That is delta G is equal to delta H minus T delta S. There are some little zeros up there, and those mean standard state conditions for the future. Okay, Gibbs free energy, that's the delta G term. That is the energy to do useful work. Then there's the enthalpy term, that is the delta H term. Then there is the entropy term, that is the delta S term. Remember, when Gibbs free energy is negative, the delta G term is negative, that means it is spontaneous. When it is positive, it is non-spontaneous. The enthalpy or the heat term, delta H, when it is negative, it is exothermic. And when it is positive, it is endothermic. When the entropy term, delta S, is positive, it is disordered and random. When it is negative, it is ordered. Okay, so here we go. For a spontaneous product-favored reaction, you should see that the delta G is always negative when it is exothermic, that is negative delta H, and ordered positive delta S. A non-spontaneous reaction is when delta G is positive and delta H is positive, that is endothermic, and the delta S term is negative, that is ordered. Okay? So you should see that when the enthalpy and the entropy are opposite in sign, you absolutely know whether the reaction is spontaneous or non-spontaneous. The question is, when the enthalpy and entropy are of the same sign, you do not know delta G. So you need to look at how large one is compared to the other. Okay? So at equilibrium, what is delta G? It is equal to 0. Okay? So this equation right here, delta G is equal to negative RT ln K. And K is the equilibrium constant. If you are at non-equilibrium conditions, you're going to be replacing the K with a Q. So there's a negative sign there. The R is the gas constant, the T is the temperature, the ln is the natural log. Got that? Okay. When the K is greater than 1, we know the reaction is product favored. And think about a strong acid. Any strong acid, the K value is huge, so large that we say it is greater than 1. Okay? If the K value, the equilibrium constant, is less than 1, then it is reactant favored. Think about a KSP problem. That is a precipitation problem. Those are all reactant favored. Okay? Delta G can also equal the sum of the delta G of formation for the products minus the sum of the delta G of formation for the reactants. So there's a lot of different ways to determine the value of delta G. It is all dependent on what information you are given in a problem. So you need to think about vectors. Okay, and determining the delta G, you need to think about, like, see these two arrows right here? One is larger than the other. The one that's larger always wins. So that means that the strong always pushes the weak, and the strong wins. So the reaction could be, if the signs of the enthalpy and entropy are of opposite sign, you know they're going in the same direction. And you don't have to figure out who wins. But when the signs of the enthalpy and entropy are of the same sign, that's both positive or both negative, then you have to figure out which one is a larger magnitude number. And that's the one that pushes the reaction forward. And that way you can tell whether it is enthalpy driven or entropy driven. Fantastic. I am bare about chemistry, and I hope that you like that video, so give it a big thumbs up.